Alright, this is section 7.2 about the law of sines. So first we're going to solve a triangle using the law of sines, and the triangles we're going to solve are oblique triangles, which means not a right triangle. Alright, we can solve oblique triangles when we know these possibilities. So two angles on any side, if we know those, then we can solve it. And those may occur in this order. You know the two angles and the side between them, or a side and then the next two angles. All right. If you know two sides and an angle opposite one of them, then you can solve the triangle. If you know three sides, or if you know two sides and the angle between them. Let's try the first two situations, which will be solved with the law of sines. Let's find out what the law of sines is first, though. So the law of sines comes from a triangle. Well, let's look at how we develop it. So let's say we have a triangle A, B, and C with sides of lengths A, B, and C, right? Lowercase a, b, and c. Opposite angles A, B, and C respectively. And it says that A over sine A of angle A equals B over sine of angle B equals C over sine of angle C. We'll begin the proof, and I won't finish it, but if we have time, like at the end of class, and anybody wants to see it, we can finish it then. All right, so to begin the proof, we draw an altitude h from the point C to the side AB in like the triangle in the picture there. Note that if we do that the sine of A is h over B, because your height forms two separate right triangles, and the sine of angle B is h over A. Yeah. If you solve for h, you have h equals B sine A. H equals B times the sine of angle A, and also h equals A times the sine of angle B. Okay, and so we can put those two together, and we can say then that B sine A equals A sine B. So B times the sine of angle A equals A times the sine of angle B. And if we divide both sides by sine A sine B, then we get B over sine B equals A over sine of A. All right, and to finish that proof, because we're missing C over sine of C, we can either flip the triangle around and redo the proof with the two that involves the two angles B and C, or A and C, whichever ones. And of course, once you have that, you'll have you can use the transitive property to write the statement that all three are equal. Okay, that's one, and there's other proofs that we can look at. All right, let's look at an example. So number one, it says solve triangle ABC with angle B is 70 degrees, angle C is 48 degrees, and side B is 15 centimeters, round to one decimal place if necessary. So first I will draw just a generic triangle with vertices A, B, and C, which means angles A, B, and C also. Fill in my numbers, so B is 70 degrees. C is 48 degrees. And let me see, it's side B, side A, and side C, and side B is 15 centimeters. So I will write the equation B over sine of B over sine of B equals C over sine of C. All right. Notice, by the way, that we can figure out the third angle already. So angle B is 70 degrees, angle C is 48, and angle A is missing, but the total has to be 180. So angle A, we fill it in red, should be, let's see, we got 62 degrees. Let me just double check that. So we'll add 62 plus 48 plus 70. And that gives us 180, so that's okay. All right, and then replace the numbers. So B is 15 over sine of 70 degrees equals C, which is unknown. So C over sine of angle C, which is 48 degrees. Okay, and we can solve. Just multiply by the sine of 48 degrees, and we'll have C equals 15 over sine of 70 degrees times sine of 48 degrees. All right, that's an exact answer, right? And then we can get an approximation. I'll do it in green. Oops, I think I might have been hiding my work there. All right, so we got 15 over sine of 70 degrees times sine of 48 degrees. Let me compute that on the calculator. And I get 11 point, C is, oops, I said I was going to do it in green. C is approximately 11.8625, etc. It says we want to round to one decimal place, so let's call this 11.9 centimeters. All right, and now I want to find side A. So I will write, starting with the same equation, B over sine B, and the reason why I use that one again is because I have numbers for that. E equals A over sine of A. All right, so B again is 15 over sine of 70 degrees equals A, which is unknown, so it's A times the sine of 62 degrees. So A will be 15 over sine of 70 degrees times the sine of 62 degrees. And if I ask my calculator, it says 14.09419, etc. So A is approximately 14.1. Okay. Also, I don't know if this indicated it, but the longest side is opposite the biggest angle. So I'm going to write the approximation. So I got C is approximately 11.9 and A is approximately 14.1. So I was saying that the longest side is opposite the biggest angle. And if we look at that, does that make sense? So 70 degrees is opposite 15 centimeters, 62 degrees is opposite 14.1 centimeters, and 48 degrees is opposite 11.9 centimeters. So those follow the right order. That makes me think that we're correct. All right. There's a second problem, and that one we'll leave for class. And let's go on to part 2, solving a triangle using the law of sines. When you have two sides and an angle, and when this happens, sometimes we have an ambiguous, or we have either more than one solution or fewer than one solutions. And so we're going to find out, how do we know? All right. So when you have fewer than one solution, that means when we have no solution, we're going to be trying to find a sign that is out of range. So for example, sine inverse of 1.3, something like that, right? Which does not exist. All right, let's do one. So we have 3 examples. And we're going to do, so the first one will have one solution. The second one will have no solution. And the third one will have 2 solutions. Let's do the third one so that we can see how will we know if it has 2 solutions or not. Okay? All right, so number 3 says, solve triangle ABC, let's draw a generic triangle called ABC, with angle A equals 40 degrees, side A equals 22, and side B equals 25. Okay, so we're missing angle B and angle C and side C. Okay, all right, so the first thing is that we do have side A and angle A, so we'll write A over sine of A equals, and we do have side B, so we'll say B over sine of angle B. All right, and if we fill in the numbers, so we have A is 22 over sine of 40 degrees equals B is 25 over sine of B. Right, and you can see where we might be maybe using sine inverse. Okay, so if we solve, we get sine of B equals 25 times sine of 40 degrees over 22. Okay, and the calculator that says that's approximately, oh, actually we can, yeah, let's say this. So sine B is sine inverse of that whole thing, 25 times sine of 40 degrees over 22. And so that's an exact number, right? But notice it's kind of unrecognizable. Let's find an approximation in degrees. Okay, so if I type that into my calculator and sine inverse, it says 46.9233, etc. So approximately 46.9 degrees. 46.9 degrees. All right, so how can there be another possibility? Well, if we remember the unit circle, on the unit circle, the sine, if sine inverse is 46.9 degrees, that's about right there. So that's the sine. Oops, I think I'm not showing you guys. That's for about 46.9 right there, let's say. So the sine is the y value, remember. But there's another y value that's the same, and it's on the other side. Yeah? And so we need to know, there's two possibilities. There's 46.9, or there's 46.9 away from 180. Okay? So if I take 46.9 from 180, I get 133.1. Okay? And then how do I know that that's possible? Well, I look at the angle that I have, which was 40 degrees. So if I add 40 degrees to 46, I get 86.9. That leaves me room for angle C, right? That leaves enough degrees for angle C. That means, so if B is 46.9 and A is 40, that's 86.9. And so angle C would be 180 minus 86.9, which will be 93.1. All right, and if angle B is 133 and angle A is 40 again, that's about 173.1. And notice that angle C would be about 6.9 degrees. So the way you know that there's two solutions is you carry out this, you check to see if that's what two angles are possible, and then you check to see if they are in fact possible by adding the three angles, or the two angles that you know at that point, right? Because we knew one, and then we figured out there was a possibility for the second one, and then is there enough degrees left over for the third one? And for these cases, yes, they were. Okay? So what we do is we say C sub 1 equals 93.1, or is approximately, right, 93.1 degrees. And we say C sub 2, that means the second possibility, is about 6.9 degrees. All right. We're going to continue on the next video.